Wow, here's something. Look at this. A little golden cube floating in the air, or it appears to be floating anyway, in between two black biscuits or something. Let me put some paper behind it and you might be able to see more clearly that this little thing is actually floating in the air. Extraordinary. It's only a few millimetres size, it's a metal. What's happening here is the gravity is pulling it downwards, but it's a magnet, so with magnets at the top, they're pulling it upwards, and when you get them just the right height, you get almost perfect equilibrium. But that still wouldn't be enough to explain what's going on. In addition to that, you need this stuff called pyrolytic graphite. It's a very pure form of graphite, which acts as a way of repelling the magnets. The bottom one is trying to push it away upwards, and the top one trying to push it away downwards. And when you get just the right amount of balance, there it sits in the middle of the air. Can't touch either. It's an extraordinary effect which was predicted in the 1930s, but I was so intrigued by it I looked around to see what else had been made, and eventually I found a little resource of versions of this, all of which are very slightly different and they're quite fun to go through. This one makes a little bit clearer what's going on inside that bell jar, because it's not a little cube of neodymium iron boron, it's a little square of it. So gravity is pulling it down. This large magnet here is pulling it upwards. If I push it away, it can't lift it. Now the gravity is pulling it down and this isn't moving. As I push this thing downwards like that, in fact, in the ultimate thing, I can just push with this and make the magnet a little bit closer. If I bring it too close, though, it whoops up in the air like that. It shoots up in the air. So it's quite a fine limit. You've only got a certain amount of distance where you can make the thing float. But float it does. Beautifully. So the first two I came across had just that situation. You had bits of magnets floating in the air over this peculiar form of graphite. Then they started making them the other way around. So this is a bit of the graphite, the very special pure carbon, floating over magnets. Underneath you've got, well, north-south, I don't know, there's a ring magnet here and a magnet in the middle there. And then on top of it now there's one of these things floating. If I give it a little blow, it rotates beautifully. Spins away, my goodness. Is it really floating? Well, yes, I can put a bit of paper underneath it with a bit of luck. Wow, look at that. Right at the end, I caught it. But it floats over the top as if it's magnet, as if it's magic. Magic. Beautiful. And then they made it a bit clearer. In fact, this is one we had on our website for a few years to sell. And here this explains a bit more about what the layout is. You've got to have a north and a north, for instance, and south, opposite sides. So south, north, north, south. That's the arrangement. Any other arrangement, and the thing simply won't float. It goes either way up, which is interesting. So this is not actually a magnetizable material. It's only carbon, but it does this curious thing of forming diamagnetic levitation. When it's sitting on a bed, they call it the Halbach array, having north, south, south, north. When I show this to some friends, they say, well, you can take it further and have many more of the magnets in an array. And in fact, a friend of mine showed me one, and I thought I must make a copy of that. So this is my rough sample of what he'd made. And here we have 100 of these in an array, which if you could see the magnetic force, it would look like a chessboard. North, south, north, south, south, north, south, north, and the next layer, and so on. And there's a 10 by 10 array, which is 100 of them, and this little piece of graphite is floating around in the middle of it. And then I managed to persuade my friend to make me up a really nice version of the thing which he'd shown me at one of our conventions in Atlanta. And this is the one that I think is my best example of this wonderful physics toy. Look at that. So 10 by 10, an array, laid out like a chessboard, if you could see them as north-south, and then south-north on the next layer. And the bits of graphite, and they're quite large pieces, can be turned upside down either way, but this way up, it's nice. They've got little faces on them. What he's done here, he's taken some of the ideas from Edwin Abbott's famous book, Flatland. I bought the book about a few years ago. It's 1895, where he imagines a two-dimensional universe, and in this universe, all these creatures have different shapes depending on the number of sides they've got, was there for status in society, I think, or something like that. And into it he introduces the three-dimensional body and makes a lovely case for looking at the fourth dimension. But this is a beautiful example of a bit of physics becoming quite philosophical at the end. So a wonderful toy to finish with. I think this is my all-time favourite version of a magnetic toy. Flatland, he called it. Why not? After the book.